Module 4, Lesson 5, Exponents. Learning targets. I discovered that 3x is equal to x plus x plus x is not the same thing as x to the power of 3, which is x times x times x. I understand that a base number can be represented with a positive whole number, positive fraction, or positive decimal. And I understand that any number a to the power of m, is defined as the product of m factors of a. Evaluate these expressions. 4 plus 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 4. 9 plus 9 plus 9 plus 9 plus 9. 10 plus 10 plus 10 plus 10 plus 10. How did you come up with an answer for each of these expressions? Did you use chunking or multiplication by adding one at a time? Or another way? Let's look at the way of adding. We can simply add 10 plus 10 plus 10 plus 10 plus 10 to give us an answer of 50. And if we were to do that one at a time, so 10 plus 10 is 20, 20 plus 10 is 30, 30 plus 10 is 40, and 40 plus 10 is 50. Adding up all those individual numbers one at a time is time consuming. So instead of adding, we can multiply. So 10 plus 10 plus 10 plus 10 plus 10 can also be written as 10 times 5. And doing 10 times 5 is a lot faster than adding up all those individual numbers, and we still get an answer of 50. So multiplying is a faster way of adding. If multiplication is a faster way of addition, is there a faster way of multiplication? The answer to that question is yes. When we multiply 5 groups of 10, we write this as 10 to the power of 5. This is called exponential form. Let's look at the exponential form closer. On the screen, I have written it again, 10 to the power of 5. So this is read as 10 to the power of 5. The 10 is the base number, and the 5 is the exponent. The exponent is always going to be floating in the upper right corner of the number, and it is written as half the size as our base number. We do this so that you know that this is 10 to the power of 5 and not 105, because those are two very different things. When writing exponents, you will usually always see it written this way, and this is how you will write it. However, if you are doing math on a computer or you're putting it into a calculator, you might not be able to put it this way. So you might see it as 10 with this little floating caret looking symbol, 5. That is the same thing as 10 with the floating 5. It's just written a little differently because the normal exponent form might not have been available on the computer or the calculator, but these two things are the exact same. Exponents are simply repeated multiplication. So if you see 10 to the power 5th, that is equal to 10 times 10 times 10 times 10 times 10. These things are the exact same. Now let's do some practice. We are going to be writing each expression in exponential form. So our first example is 5 times 5 times 5 times 5 times 5. So when we are writing something in exponential form, the number that we are multiplying by is going to be our base number. So our base number is 5. And then we just have to simply count up all the times we're multiplying 5. So we're multiplying 5, 1, 2, 3, 4, 5 times. So then it's going to be 5 to the 5th power, or 5 to the power of 5. Our next example is 2 times 2 times 2 times 2. Our base number is going to be 2 because that is what we are multiplying by. And then we are multiplying 1, 2, 3, 4 times. So 4 is going to be our exponent for an answer of 2 to the power of 4. Now we're going to do it backwards. We're going to write each expression that is in exponent form into expanded form. And when we are writing something in expanded form, that means we are going to be multiplying each number. It's going to be written out longer. So our first example is 8 to the power of 3. So we know our base number is 8, so we're multiplying by 8. And then our exponent of 3 tells us we're multiplying 8 3 times. So in expanded form, it is going to be 8 times 8 times 8. Our next example is 10 to the power of 6. Our base number is 10, so we know we're going to be multiplying by 10. And then our exponent is 6, so we know we're going to be multiplying 10 6 times. So 10 times 10 times 10 times 10 times 10 times 10. Our last example is g to the power of 3. So this doesn't have a number. Instead, it has a letter. And sometimes we're going to see that. And that just simply means that g is our base number. So we're going to be multiplying g by the exponent, which is 3. So 3 times. So it's going to be written as g times g times g. So whether it's a number or a letter, it's still the base number. So now that we've practiced writing our exponents in exponential form and then taking exponential form and turning it back into expanded form, we're going to practice turning answers into standard form. And standard form means that we are just going to be solving the expression. So we have 5 times 5 times 5 times 5 times 5, and that's expanded form. And then if we turn our expanded form into exponential form, we have 5 to the power of 5. We have an answer of 3,125. And yes, you can use a calculator, and you can use the calculator to do 5 times 5 times 5 times 5 times 5. Or if your calculator does exponential form, you can do 5 to the power of 5. Calculators are allowed here because that is a lot of multiplying. Our next example is 2 times 2 times 2 times 2, and that is expanded form. So in exponential form, we have 2 to the power of 4. And then for standard form, we have 16. And our last example is 8 times 8 times 8. That's expanded form. Exponential form, we have 8 to the power of 3. And then standard form, we have an answer of 512. So base numbers don't have to be only whole numbers. They can also be decimals or fractions, and they work the exact same way. So we have 3.8 to the power of 4, and as you can see, the 3.8 is actually in parentheses. This tells us that 3.8 is being multiplied 4 times, or 3.8 is going to be to the power of 4. Because if we wrote it this way, 3.8 to the power of 4 without the parentheses, that looks like only the 8 is being raised to the power of 4. and that's not what we want at all. So decimals and fractions will be written in a parentheses, so we know that that whole number is being raised by the exponent. So now that we have discussed that, let's put 3.8 to the power 4 in expanded form. So we are going to have 3.8 times 3.8 times 3.8 times 3.8. And then in standard form, it is 208.5136. Our next example is 2.1 times 2.1. So this time it's in expanded form, and we have to write it in exponential form. So we're going to remember to put 2.1 in parentheses, and then it is being multiplied twice, so it is going to be to the power of 2. And then in standard form, it is 4.41. Now we have an example with fractions. So we have 21 tenths times 21 tenths. And like I said previously, we're still going to be writing this in parentheses when we write it in exponential form. So we're going to have parentheses, 21 tenths, parentheses, and it's being multiplied twice. So that is to the power of 2. And then in standard form, it is 441 100ths. And if your test, quiz, problem set, whatever you're working on doesn't say to simplify, you can leave it like that. Perfectly fine. If it says to simplify, then you need to remember to simplify. And our simplified answer is 4.41. And our next example is 3/4 times 3/4 times 3/4. So in exponential form, don't forget the parentheses. So 3/4 be multiplied 3 times, so that is to the power of 3. And then in standard form, that is 27/64. Now let's talk about how we can write expressions. If I give you x to the power of n, how could we write this as an expression? And no, there's no numbers. And yes, I know that. So if we want to write this as an expression, it would look something like this. So in parentheses, we have x times x times x dot 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 x. And the dot means to multiply. We are using dots because we also are using the letter x, and that would get a little confusing. So a dot means that you are multiplying. And then under it, I have the little squiggly that says n times. This just tells us that we are going to be multiplying x by n times. So if we're solving a problem that says, so x represents the factor that will be repeatedly multiplied by itself, and n represents the number of times that x will be multiplied. Now, what if I gave you a problem that just said 4n, and I wanted you to write it as an expression? This would mean that we are going to be writing 4 plus 4 plus dot 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 4 n times, because 4n means that you are adding 4 by however many times n is. So that's not the same as the last example, because in the last example we were multiplying. In this example we are adding. So 4 represents the addendum that will be repeatedly added to itself, and n represents the number of times 4 will be added. Lesson summary. So exponents are going to be written as 10 to the power 5 or a to the power of n, whichever, and the exponent is always going to be smaller than the base number and is always going to be floating in the right hand corner. So our number 10 is our base and 5 is our exponent. And lastly, 4 to the power of n is not equal to 4n, because 4 to the power of n means that you are multiplying repeatedly, and 4n means that you are adding repeatedly. Now, go complete the problem set.